Hi, today we have another variant Sudoku. This one features yin-yang shaded and unshaded rules. We're going to shade some of the cells in the grid so that the shaded cells are orthogonally connected, the unshaded cells are connected, and no 2x2 square is either shaded or unshaded. Additionally, we have crop key dots, and every dot must touch a shaded cell, and within the shaded region, we have German whispers rules. All right. Not a lot to go off of looking at the board. Now, before we look at the data or the few clues we are given in the form of crop key dots, I'll mention two things that one should know about yin-yang rules, which is I'm going to use green to indicate shaded regions and blue to indicate unshaded regions. And with the given rules, it is impossible for a 2x2 region to look like a checkerboard. That is the first thing to know. And it is the second thing to know about these rules is that on the circumference of the board, the shaded and unshaded regions must be contiguous. There can be at most one block of shaded cells, and at most one block of unshaded cells. You can't have 2 blocks of shaded cells or 2 blocks of unshaded cells. Neither of these facts are hard to prove given the yin-yang rules. So if you haven't seen these before, I encourage you to think about why both of these things must be true. But on to our specific puzzle. Now we know, per the rules, at least one of these two cells is shaded. And we also know it's impossible for them both to be shaded, because if they're both shaded, and this is going to be true for every black crop key dot, and every white crop key dot as well. Okay, well, let's look at white crop key dots first. If two white crop key dots if the two cells on both sides of a white crop key dot are both shaded, then they differ by at least 5 by the German whisper rule, but by the white crop key dot rule, they are consecutive, which is obviously impossible. And the same can be said of black crop key dots, because 2 digits that are in a 2-to-1 ratio can be at most 4 apart if they're 4 and 8. So we know the two cells can't both be shaded, and we are told they can't both be unshaded. So therefore, whenever you have two cells connected by crop key dot, exactly one is shaded and one is unshaded. So not knowing the shadedness status of these two cells, we know that they form this pattern, and because a checkerboard is impossible, that one must be yellow as well. And similarly, those 3 are the same, but that could be those 3 are yellow and that is peach, or it could be that these 3 are peach and this one is yellow. Not clear. But no, this is informative here. So let's drop this. Okay, suppose this is peach. It touches 2 yellows, where I'm saying peach and yellow are shaded and unshaded in some order. I don't know which. Now, because we have no... that didn't do what I was looking for. I like to start with the outside region when working with yin-yang rules, because I know, in some order, one of these is shaded, one of these unshaded, and because I can have a maximum of 2 of these transitions on the board, if I knew, say, this was one of each, then I know all of these are the same and all of these are the same. But I only have 1 crop key dot on the border. And this could go like this, or it could go like this. That is somewhat constrained. I wonder if we can use the German whisper rules profitably. So suppose this is high and this is high and then this is low. Right. That can't work, can it? So let's suppose for a moment that these are in the shaded region and this is unshaded. Now if this is low, then these are high because the shaded region alternates between low and high. And then because this is high, it must perforce be double this, and then this is impossible. The alternative to consider is that this is high and these are low. That is much more plausible. Obviously, this is not going to be 6, but don't worry about it. This is adjacent to 1 through 4, so this has to be 1 through 5. 5 can't be on a crop key dot. So we could have 3, 2, 1 is valid. 3, 2, 1, and this is 8 or 9. We could have... Okay, neither of these can be 3, and consequently this can't be 4. This could be 4, 2, 1, 9. 2, 4, 3, 8 or 9. This can't be 1 because that makes both of these 2. And then 1, 2, 3, 8 or 9. So if these are shaded and this is unshaded, this gives us the full gamut of possibilities. But what about the converse? I think with the converse we have nothing, right? Because there are no constraints about how these 3 digits relate, and this could be anything. What about here? I think here this is no problem at all. Just these differ by 2, and then this is low. Or you can switch low and high symmetrically. Maybe this is a starting point. I mean, let's try. Now, if we do this way, then it has to look like that. Oops. And if we go this way, we're unconstrained. And once again, we can have this. I just did the same thing twice in a row. Yes. Well, okay, I think we shouldn't start with the dots at all. So you can never have a 5 in the shaded region. And that tells us that in every single, all 4 sides of the board, there's at least one unshaded cell somewhere, because there's a 5. So for example, here, 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 whatever. And consequentially, since we know at least one of these is shaded, yes, there can be no shaded cells here. Because suppose otherwise, that any one of those cells is shaded, say here. We know one of these two is shaded. It follows that either this is shaded, making the entire left column shaded, or this is shaded, meaning the entire top row, minus this cell, is shaded. If this entire column is shaded, then there's a 5 in the shaded region, impossible. If this is shaded, then either there's a 5 in a shaded region, or there's a 5 in a black crop key dot. Either way, it's impossible. It follows that all of this is unshaded. Now we can make some deductions. We know these three are the same as each other, and if they were all unshaded, we'd have a 2 by 2 unshaded region. Therefore, they are shaded. We know these two are opposite, and we can't have a checkerboard shape, so it must be the other way around. Now what? So we can make some deduction here, but let's set that aside for a moment and think about what else is going on. If we have this dot colored in this manner, that seems fine. And of course the other way is also fine. These three are the same color, these three are the same color, again, it's all fine. So one of these is unshaded. It follows that either these are unshaded or these are unshaded. How about we can work bit by bit. This cannot be shaded because then it implies all of these are shaded when you have a 2 by 2 region. For whatever good that is worth. Yes, maybe here is the next place to start. I recall arguing that this can't be low. Because if this is low, this is high. This is high, this is half of that, and then these two are consecutive, which is obviously false. It follows that this is high. And I think I'm going to flag the high cells in red. By high, I mean 6 through 9. By low, I mean 1 through 4. So if this is 6 through 9, and then obviously it's not 7, 9. So therefore this is 3, 4, and this is 5, 7, or 9. This cannot be 6, because then these would both be 1. Similarly, this cannot be 6. This cannot be 7, as we saw before, because that would make this a 1-2 pair. Then whichever one of these is a 1 forces this to be 2, and we have two 2's in the same box. So this is 8 or 9. If this is 4, well, hang on. Okay, this cannot be 6, so this is not 3. So this is 1, 2, or 4, meaning this cannot be 4. I think we've caught up on all the deductions that we had previously made over here and copied over here, plus the additional deduction that this cell cannot be 4, because it sees a 4. Well, this is a quadruplet of high cells, which is to say they are 6, 7, 8, 9 in some order. This is 5 through 9. It does feel like it's going to be quite hard to get digits on the grid. One, 2, 4, 8, 6. I mean, that's not specific. Can we determine which of these is shaded based on its parity? If this is shaded, it is low, high. If this is shaded, it is high. Therefore, it is 6 or 8. Therefore, this is 3 or 4. I suspect here we can use parity. If these 3 are shaded, oh, then this is high again. That doesn't help us at all. That's just consistent. High, 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 high. So if these are shaded, then these are high. If these are unshaded, then this is low, and therefore these are all low. Maybe that is useful. Suppose this is shaded and this is unshaded. We know this is high. Therefore, all of these are 5 and up. Meaning at most one of these two can be shaded. Which doesn't seem like much of a contradiction, really. Suppose this is shaded. It follows these are shaded. And that this is unshaded. And that does not give us a deduction here. High, 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 high. These are high. Shaded, unshaded, shaded, unshaded. Suppose this is unshaded, then all of these are unshaded. Shaded, unshaded. Shaded, unshaded. So it could be shaded like that. again, not much to go off of. I feel like at this stage in the Sudoku, I always find myself returning to the rules to see if there's something I missed. We do have a lot of unshaded cells here. Sorry, not unshaded, low cells here. So if this were shaded, we'd have 1 through 5 in order, in some order. These cannot all be shaded because then we'd have 6 through 9 and one of 6 through 9 is taken. Oh, if this is shaded, then not only do we have 1 through 5, you know, this is the 5, this is a 4. So these are 1 through 3. It does feel like it's leading us that way to make this deduction. Otherwise, what is this dot doing here? But maybe this is later when we have more filled in. This cannot be shaded because then we'd have 5 low digits in a row, which is impossible. To be clear, this is 1 through 4, this is 1 through 3. We've already found all of 1 through 4 in the row, so this one cannot be shaded. Now I feel like we have progress in this column. We used what we had before about how all of these must be high. All of these must be 5 or higher. Now, if these were shaded, then this would be high. This would be low. That's just fine. Both of these are high. I think I don't see a problem here. I was expecting some kind of a problem. The other way, is that a problem? This will be low. I mean, that's even less of a problem. We have an issue here. It's not an issue, really. Maybe this is a problem. So here, we now have all the high digits, but then these are just low, which is fine. Then this has to be unshaded. That is a contradiction because of this column. Okay, let's work that through carefully. Suppose this cell is shaded. Follows that these are unshaded. We now have all of the 5 and higher digits in the column. So this cannot be shaded. It must be unshaded. Now this is low. Well, this is 1 through 4. This is is 1 through 5. This is a high cell, so it's 6 or 8. This is 3 or 4. Why did I think this was going to be 5? This would have to be now 5. This would be 4. This would be 3. This would be a 1-2 pair. This is looking suspiciously possible. Six. Oh, and I'm mixing up the colors of my crop key dots. So there was no contradiction here at all, even if this one wasn't a 5. Okay, so again, this has to be 6, 8. This has to be 5, 7, 9. This column is actually unconstrained. This is 3, 4. 1, 2, 3, 4, 5. Yeah, that all seems fine. Okay, suppose this is shaded. Follows, I mean, so this is high, this is high, this is high-ish. Then this has to be 1 through 4. So this must be unshaded. This can't be 3. This has to be 1, 2, 3, 5. Can't be 5. This has to be 6 and up. Does anyone smell a contradiction? I don't. Like, obviously I know this can't be 6 and so on, but I don't think that's gaining us a contradiction here. Can't be 2. Can't be 1. I thought this was a huge lead. Maybe I can do better if I can determine that one of these is not a 6. So if this is a 6, then obviously this is unshaded. Seems fine. 6, 1, 2, 3, 8 or 9, 7, 8 or 9, 7 or 9. If this is a 6, then these can't both be shaded, and these can't both be shaded, but it's fine. This is a 6, this is also unshaded. This time this is the 1. If this is a 6, this is a 1. Can't be 4. Oh. Maybe that was what we needed to say. So if this can't be 4, we have 1, 2, 3 in the row. Well, I got some digits. I have to feel good about that. Now this can't be 6. One of these is 6. Specifically, it's paired with the 1. I feel like I should now retry what I had here before and see if, knowing that this is a 4-2, we start hitting contradictions better. Because that makes this hard to be low. Right? Let's suppose this is shaded. Now this is low, which means it's 1 through 4. It can't be 4, it can't be 2. If it's 1, 2, that's a contradiction. If it's so then it has to be 3, 5. I don't love it. Wait, 3, 5? I have no idea where I'm coming up with these things from. If this is 1 or 3, this is 1 or 3. 1, 2, impossible. 3, 2 or 4, impossible. Okay. Finally, we have a lead. This cannot be shaded. It is unshaded. And now, we have been overflowing in high digits, so this must be a 5. High digit, high-ish digit, can't be a 5 since this isn't a 6. We have sufficiently many high digits in the row. Well, one of these is an 8, this is not an 8. But this cannot be shaded. This is the high digit. These are low. 1 or 3. Yes. Let's not mix up and say that 3 and 5 are consecutive again. 1 or 3, since it can't be 2 or 4. Therefore this one is 2 or 4. Therefore this one is not 3. This is the only place a 3 can show up in the row column. 2, 4, okay, that checks out. 1, 4 would be impossible, but other combinations are valid. This cannot be 6, because it touches a 2 or higher. Seven or 9, this is odd, therefore this one is not odd. Therefore this one is odd. If this is 6, they're both 7. Possible. If this is 8, they can be either combination. Can't have a 2x2 box. Oops, other way. Now it's feeling like it's coming together a little bit. 1, 2, 3, 4, 2, 5. Can't be 1. Two, 4, 8, 6. If this is shaded, it's high, making this high. Not so bad. Okay, so let's suppose this is shaded. What do we know? We know this is unshaded. We know these are unshaded. We know this is unshaded. We know this is shaded. This is low, it must be 1. Max that to 2, that's impossible. Therefore, it's unshaded. And finally, we have progress. This could be either way, depending on what we need for connectivity. Let's put in some highs. So this has to be a low, and it can't be 3. If this is 3, we have 8, 9. Okay, this is obviously not 6 or 7. I see a 7, 8, 9 triple, therefore this is a 6. Therefore this is a 2. 8, 9 indeed. 3. What are we missing in this column? A 1 and a 5. I think that checks out. This is a high digit. Must be 8 or 9 again. Can't be 4. So one of these is 4, touches the 9. One of these is a 1, touches the 8. 1 or 4, this is not 1 or 4. We have 8 in the row, 2. And then we're missing 5, 6, 7. Okay. And then these are all high-ish. No 2, no 2, therefore these can't be 1 either. Therefore one of these is a 4. This is a high, it is an 8. This is a 4. If this is shaded, I should say. If this is shaded, it's a low, it's a 2, 3, or 4. What can I say about these? 6, 7, 9, yeah? If either of these are shaded, now, if this is shaded, it's a 1. This is a 2. These are a 3, 4. This is a 3. This is a 4. This is a 5. Okay. How about no 2s? That's something, right? Okay, 3, 4. This cannot be 1. This is a 3, this is a 6, this is a 4, this is an 8. So if this is shaded, it's a 1, this is a 2, this is a 3, this is a 4, this is a 4, this is a 5, this is an 8. That all seems consistent. Also, this is a 7. Oh wait, if this is shaded, then all of these are shaded. And we have 5 low digits in the row, which is impossible. If this is shaded, it's a 1. I rank that as plausible. This is shaded, it's high, 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 high-ish. These are 1, 2 pair. Also, this is shaded, making this one a 1. This cannot be shaded because it sees a 1, 2, 3, and 4. It does feel like lows are the good workable points. If this is shaded, it is either a 3 or a 4 to go with this. If this is shaded, it can't, it's 2, 3, or 4. So either it is like this, and this is high, or it's like this, and this is high. Let us suppose it looks like this. Ah, that looks like a contradiction. If this is unshaded, then this is shaded, then this is unshaded, then this is unshaded, and we don't have a shaded cell on the crop keyboards. That's not true. So this is shaded, unshaded, and now we have a low and a high. 6, 7, or 9, I guess. This can be 8 or 9 since it touches this. 6 and up. 6 and up. 2, 1, 6. That 2 I know because of this one. If this is shaded, that feels weird, right? Oops. Yeah, that's not right. If this is shaded, then this has to be, yeah, because this is unshaded. And now this could be either way. This is 5, 6, and 7. No 5. And we do have the 1, 2 pair we were discussing earlier. In this row, why did it select funny? 5 must be here. 6 could be several places. 8 must be here. Consequentially, this is a 3. Nine is here, implying a 9 is here. This works either way with the shading. If this is shaded, it is high, making it a 7 or a 9, specifically a 9. We actually have quite a few 7s. Well, I say quite a few, I mean 4. Not a 7. One, 3, and 5 in some order. Five, 6, and 7 in some order. One of these is a 5. One of these is a 9. What are we missing here? A 9 and a 2? Really? Okay. So if this is shaded, it is the 9. It does feel like the next step is not a shading deduction. One of these is a 1. Oh, this can't be a 9. Because there's a 9 here. It's gonna be a 7. Okay. So this can't be shaded because it touches a 2. If this is shaded, it's a 1, which is fine. If this is shaded, it's an 8, 9. Again, that's fine. If this is shaded, it's a 1, which is obviously impossible. If this is shaded, it is a 9. If this is shaded, it's a 2. Do we get a contradiction out of that? Two, 9, 1 or 3, 2, 4. This looks very likely to be the case. So can we disprove the opposite? This has to be an 8, 4, seems hard. If this is shaded, it's 8, 9. If this is shaded, I said it's a 9. If this is shaded, it's a 9. Well, it is a 9 regardless. If this is shaded, either 1 or 2. This is a 9. This would be a 9. Ah, this cannot be shaded because it can't be a 9. That is something. Is it something we want? Don't know. This would have to be 1, 2, or 3 if shaded. Now, if this is shaded, we have a real problem. Therefore, it's unshaded. If this were unshaded, then we would have to do that. This would be an 8, 4, 1, 2, 3. One of these two would be a 9. This would be a 3. All in all, that also looks plausible. How do we distinguish which of these plausible scenarios is correct? Presumably it is by making deductions elsewhere in the grid. It feels like this being shaded, which forces it to be a 3, is problematic. I'm going to mark in corner marks if I know what a cell is, conditional on it being shaded. So this one is a 9, this one is an 8, this is a 4, this is an 8. But if this is shaded, we simply know it is, we know it's 2. Because it's next to the 7. If this is shaded, it's a 3. If this is shaded, it's a 1, 2, or 3. If this is shaded, it's a 1. So if this is a 3, it could connect like this. That would be a contiguous block. That works. It'd be this. 3, 8, 9. Or instead of that, this. 3, 8, 9 this way. No, but then yeah, that's a problem. If this is shaded, this cannot be shaded. If this is shaded, this is shaded. Yes? Because if this is shaded and this were shaded, then this would be unshaded, this would be shaded. Yeah, it's all contradiction. Okay, so if this is shaded, this is shaded, this is unshaded. I guess you could do that. One of these, doesn't matter which one. I feel like I am supposed to be making deductions elsewhere in the grid to narrow things down. Like, surely I know a lot about these cells. Do I know where the 1 and the 2 are? Not really. This is a 6. One, 2, 3, 1, 2, 3, 1, 2, 3. Yeah. Proving one of these is the 3. Just making logical sense. This is not the 3. It's a 5. This is a 7, 9. This is a 3. Okay. This is 1, 3, and 4 in some order. This one can't be the 1. If this is a 2, we have 1, 3. That's all fine. I know 2 is in this column. I know 2 is one of these two digits. Eight's in this column. Well, 8 is one of these two digits. Even better. 9 is here, 5 is here. 5 sees this. Okay, well that's something. 1, 5. 6 and up. Yep. In this column we have 1 through 4, so we have 5 and up. There must be a 3 and a 4 here. Along with what? Hard to say. Again, it feels like the central box is where progress is being made. No 5 here. Okay, we have an 8-9 pair in the column. Four, 8, 9. This is neither 4 nor 8. If this is shaded, we have an 8-9 pair in the row. And then this is either 2, 3, or 4. If these are both shaded, we have 3, 9, dismissing this. Yes, one of these is a 5. Does it help us at all? It tells us it's unshaded. So if this is a 3, then this is a 5. But I mean, you can just shade this way. And leave these unshaded. If this is a 2, this is a 4. If this is an 8, this is a 4. So either way, we have a 4. At this point in time, I'm suspecting that there's some relationship where, like, if this is shaded, then we can conclude something here, and then you get a relationship between this being shaded being a 1, forcing something that feeds back, and you show one of the two ways fails. But I don't know. If this is a 2, 1, 3, 2, 2, 1, 9. Well, 9 if this is shaded. Oh, well. Or there's just that. So this is unshaded, so this is shaded. So this is the 4, this is the 8. Where were we? I know there's more here. Well, logically there must be IS. The shading must escape. Therefore that's... What do we have left over? 2. All right, now just the numbering. Well, it's 8, 9, 8, 9, 9, 7, 6, 8, 6, 7, 9, 6, 1, 2, 2, 3, 1, 5, 7. What are we missing? Okay, that was a little bit harder than I was expecting. But as always, I do like yin-yang rules. That was fun.